Not the worst jumpering job I've ever seen, but we can clean this up and eliminate the need for the jumpers altogether. Several of the chips on this board had been socketed, and when the original chip was taken out, some through holes were torn and pads were scraped off. Here I've cleaned up the pads and used a through hole replacement rivet where the trace is on the component side of the board. Tinning the pads is important. You'll note in the upper right corner I didn't rivet that one since the trace is on the solder side of the board. A TriZone MPU and driver board. And these things were disasters, but I've got them working now. Number one, all of these sockets, my granddaughter's here to help me. All of these sockets needed to be replaced. Sockets for the microprocessor and the 6821. The 40-pin header had been replaced by the client, but I replaced all these other headers, the power header being the most important. There's display blanking and diagnostics and the 3 display headers. I replaced all the headers on the driver board also. Replaced that 5-volt cap that just passed by. This 5-volt cap up here also. The main problem was that every single one of these 7402s or 7406s that's in a socket right now were blown out. So they were causing the game to not operate correctly. There were a couple of transistors there with the gold tops that I had to replace. And there was a couple over here that I haven't marked yet in the or the lamp matrix that I replaced also, but I haven't marked those yet. So let's get it into test. Harper, we're going to put it into test. I'm going to turn off the light so we can see a little better. The auto up, manual down switch in the correct position. So the displays are working. And lamp test is working. And now let's do the diagnostics on the solenoids. And the only solenoid that's on right now is solenoid 16, which is a coin lockout solenoid. Watch out, sweetie. And it will turn off when it comes past this time. And then if we let it go long enough, it'll turn back on. There were a number of failures in the special solenoid section, which just showed it's working right now. And let me run the special solenoid section by the switch inputs. I'm gonna get this connector grounded.
Having grounded?
I'm gonna ground that, Harper. Yeah. And looks like it passed there. All right, there's 1, 2, 3, 4, 5, 6. And I do that by using my test tool to ground those specific input pins. Test 3 is the switch matrix, and TriZone has 35 switches. Let's do all of column 1. And then we'll go across the row. 35 switches. That seems unusual, but there we go. There's all 35 of those. Watch out, sweet pea. And then it goes back to the audits and adjustments. And I'm just going to scroll through those. I should have, well, let's see. Well, I don't have a NVRAM on here, so it won't do me any good to set it to free play. I did add a blanking indication with a label of what the LED on means. It's a beautiful orange blanking LED. And I left it up to the client to decide whether or not they were going to install NVRAM. The 5101 is already socketed, or if they want to install a memory cap or whatever they want to do. So I'm going to reboot and show you the lamp matrix. And all is well. Thank you so much for sending it.